Good morning. Today we are going to discuss few more applications of operational amplifier like subtractor, differentiator and integrator. In previous lecture, that means lecture number 2, we have discussed some applications like adder and some others. So let us discuss these one by one. This is the diagram of difference amplifier, which is also called as subtractor, because this circuit can provide difference of two inputs. So due to this reason, this circuit is also called as subtractor, because indirectly it is providing subtraction of two inputs. So let us analyze this circuit. How does this circuit will work and how it can provide the difference of two inputs. So first of all, let us see how does we have connected these resistances. As you can see, there are four resistors which has been taken. One is the feedback resistor R3 and R1, which is connected to first input V1, and R2, R4, which is connected to voltage V2 like this. And all of you know that the concept of virtual ground will work here. We are considering that this is the voltage VA and this is the voltage VB. So by virtual short circuit concept, which I have discussed earlier in previous lecture, by virtual short circuit, VA will be equal to VB. So our task is to find out this voltage VB. Let me clear this. So our task is to find out VB, and let us see how to find out VB. We can see this VB will equal to the voltage R is equal to the voltage V2 multiplied by this resistance which is connected to the ground, that means R4, upon the total resistance R2 and R4, that means R2 plus R4. So now we can solve this circuit in two ways. One way is by considering this current I1 is equal to IF and VA is equal to VB, but this method is somewhat complex. So easiest method is to consider this voltage V1 first time and consider V2 as 0, and second time we'll consider this voltage V2 and we'll connect V1 to ground, and whatever individual outputs we find out by considering V1 and V2, finally we will add these two, and it is the simplest method to find out the output of this difference amplifier. So if I will consider if V2 is equal to 0, then this circuit will convert into the inverting operational amplifier. And you know, gain of inverting amplifier is minus this resistance divided by this resistance, and to get output we will multiply minus R upon R1 by V1. So you will get V output A by this if we consider V2 is equal to 0. Okay, rest thing we have already discussed, like this. Okay, and if you will consider V1 equal to 0, that time what will happen? This whole circuit will convert into the non-inverting amplifier, because we'll apply input at V2 only, that is non-inverting terminal. And you know that the gain of non-inverting terminal is R1 plus R3 divided by R1. Okay, and the input voltage, that means the voltage which is appearing at the node VB, is this, which we have already found out, V2 upon R4 upon R2 plus R4. Now, these are the two inputs. One is this. When we are considering V2 is equal to 0. Second one is when we are considering V1 is equal to 0. And we are getting the corresponding outputs like this, V output A and V output B. Now the final output by considering both V1 and V2 will be the summation of the two individual outputs. So, two individual outputs are this and this. So, let us add these two. So, we will get final output like this, minus V1 R3 upon R1 plus V2 into R4 upon R2 plus R4 multiplied by R1 plus R3 upon R1. So this is the final output of the difference amplifier if we are considering R1, R2, R3, R4 have different values. And if we will consider R1 is equal to R2 and R3 is equal to R4, then this equation will be simplified to this V output is equal to R3 upon R1 V2 minus V1. And even if you want that you should get only the difference of two individual inputs. This, by considering R1 is equal to R2 and R3 is equal to R4, you can amplify the difference V2 and V1 by any factor. For example, if you want the output is equal to 3 times V2 minus V1, then you can opt R3 upon R1 is equal to 3. That means you can consider any value. R3 is equal to 3 kilo ohm, R1 is equal to 1 kilo ohm, R3 can be if R1 will be 5 kilo ohm, then R3 should be 15 kilo ohm. Like that, you can choose any value if you want the amplification of this difference. Okay. If you want only difference, that means V2 minus V1, then we need to consider this R3 is equal to R1. If R3 is equal to R1, then you can simply say that V out will be equal to V2 minus V1. And we have already considered R1 is equal to R2, R3 is equal to R4. That means if we will consider all resistances of equal value, then we will get output as the difference of two individual inputs. Okay. And one more interesting thing is, here one input is positive, which is we are getting an output, and one is negative. And all of us know that if you will apply input at inverting terminal, at the output we will get phase shift of 180 degree. That means you will get negative output. And if you will apply input at non-inverting terminal, that means positive terminal, then output will be in the same phase of that input. That means if input is positive, then output will also remain positive if you are applying input at non-inverting terminal. So see here, according to our concept, V1 should be applied at inverting terminal. Yes, V1 is applied at inverting terminal. So whatever concept we have studied in inverting amplifier and non-inverting amplifier is applicable here also. So this is which we have to discuss in difference amplifier. Next application of operational amplifier is differentiator circuit. That means a circuit which can provide differentiation of the input. This circuit, you can see here in this circuit we are using, this is the first circuit which we have discussed in 3 lectures, which contains capacitor. Till now we have discussed the circuits which contains only resistors. So differentiator and integrator circuits will consider capacitor. And this circuit have capability that V0 will be proportional to the differentiation of input. Let us see how does this circuit will provide the differentiation of input. So to analyze this circuit, actually we all know that current through resistor is equal to the potential difference divided by the resistance. I just want to consider one concept, that if this is the capacitor, then what should be the current through this if we have applied voltage V1 and V2 across the capacitor. Actually, you know, Q is equal to CV, where Q is the charge, C is the capacitance, and V is the applied voltage. So you can differentiate both these sides. dQ upon dt, C is constant, dV by dt. So you can write this dQ by dt is equal to I. So here you can write I is equal to C dV by dt. So what is the voltage V? V is the voltage which is applied across the capacitor. So in this case, if I will consider V1 and V2, which I have mentioned here, then I should be equal to C d V1 minus V2 upon dt. And please don't get confused that whether this V1 and V2 will be AC or DC. If they will be DC, then obviously this differentiation will be 0. And we know in case of DC, 0 current will flow. If it will be AC, only then current can flow through capacitor. So now let us analyze this circuit. And one more thing is, we are applying input at the inverting terminal and we have connected resistor and feedback, and capacitor is connected near to the input voltage. Now, we will use the basic concepts, like the current which is flowing here, I should be equal to IF, and this current will be equal to what? Q. dQ upon dt is I, so we will consider this current I is equal to C dV by dt, where this V is, let us consider this is the voltage VA, and this VA will be equal to 0 by virtual ground concept, and the current which is flowing here, IC, will be equal to current IF, and IC will be equal to C d VI minus 0 upon dt, and the current which is flowing in the feedback path will be equal to this VA minus V0 upon R. So in this way you can solve, and you can find out output voltage is equal to minus RC dVi upon dt, where RC is constant. And if you consider RC is equal to 1 second, then output voltage will be equal to minus dVi upon dt. That means we are getting output as the differentiation of input. Okay, so this is how the differentiator circuit will work. You can take any waveform at the input and you will get the differentiation of that waveform at the output. However, I will consider one waveform later on after discussing integrator circuit. So the integrator circuit is one which provides the integration of input, or output is proportional to the integration of input. So you can see this circuit is very similar to the differentiator circuit. The only difference is we have interchanged the position of resistor and capacitor. Rest everything is same. And the same concept will be applicable here. That means the current which is flowing here through resistor will be equal to the feedback current, and this voltage VA is equal to 0 by virtual ground concept. So let us see. Actually, this I current will be equal to VI minus VA divided by R, and the feedback current is equal to, which we have seen earlier, that I is equal to C dV by dt. So C D, this is one voltage, VA is equal to 0, and another voltage is V0, which is applied across the capacitor. So this is the equation which we will get at the output. dV0 is equal to minus VI upon R. So it is very similar to that of a differentiator. The only difference is we have to change the position of resistor and capacitor. Due to that, there is a difference in the final output. So if we will integrate both the sides, left hand and right hand side, then we will get output V out is equal to minus 1 upon RC integration of VI dt. Okay. So if you will consider RC is equal to 1 second, then you will get V0 is equal to minus VI integration of dt. And one more thing is that if you will consider any value of RC, that time also V0 is proportional to the integration of VI dt. It will always hold. So due to this region, this circuit is called integrator circuit. And you can see here in integrator, in case of integrator as well as in case of differentiator, the output is negative. You can see here this negative sign. Similarly, in case of integrator, there is a negative sign, and this negative sign simply indicates that there will be a phase difference of 180 degree between input and output. Okay. Why we are getting this negative sign? Because we are applying input at inverting terminal. Due to this region, we are getting output. We are getting output which is 180 degree out of phase. That means there will be a negative sign in output. Yes. So this is integrator circuit, and if you apply a rectangular wave to the integrator circuit, you will get triangular wave at the output. And we all know that integration of this waveform is triangular wave. And in case of, this is the differentiator diagram, and in case of differentiator circuit, if you apply triangular wave, you will get the rectangular wave at the output. So you can prove it in electronics labs also. Whenever you will design any circuit of operational amplifier, you can always use these circuits, means integrator and differentiator, and you can verify by applying these inputs, this input for the differentiator amplifier and rectangular input for the integrator amplifier. And you can take these waveforms from the function generator, and you can observe the output at the CRO, DSO, whatever. So this is which we have to discuss today. Thank you.